express each value as a trig function in quadrant 1. So, trig values in quadrant 1 are the easiest to figure out, right?
Yeah.
So if you can change any unit circle problem into a quadrant 1 unit circle problem, it does help. Okay. So something like, say I give you the sine of 420 degrees. Can you make that a quadrant 1 unit circle problem?
Wouldn't it already like
Okay, so what we want is sine of something in quadrant 1. So this number. How do you get that, Tyler? One revolution is 360, right? We go 60 more. It's 420. Right. So we end up in quadrant 1 with our value. Do they know what the answer to that is? We've got a unit circle quiz coming up.
For 60 degrees?
Sine at 60 is?
Pi over 4.
Okay, that is the sine at pi over 3 radians, right?
Yeah, which is... I'm doing
You do have to include radians on this one.
This is terrible.
What do you have?
All right. Okay, so keep that in mind. It does make your life easier once in a while. Okay. You want to look at the opposite angle identities.
The what?
Probably. Sure.
Yeah.
They're handy. Okay, let's stop learning. Thank you very
That's what he said.
Okay, here's the opposite of sine of an angle, right? It's an opposite angle identity. What do you think's in the parentheses?
Letter A.
Yeah, this is A. Could be X, could be theta, could be whatever.
Oh,
Sine A minus 360. Sine.
No, good guess, but no.
Over sine
So basically what you're looking at is if you get something like the sine at negative pi over 3, you can solve that by doing the negative of sine at pi over 3. Again, quadrant 1, and then just negate. Okay, so right, so negative root 3 over 2 is sine at negative pi over 3. You're using your identity to have to remember less information, but you have to remember the identity. So it's really not.
Would that be the same as just flipping it over the y-axis?
Yeah, that's what you're doing. Is you're flipping it over the x-axis actually.
she's supposed to be cute.
So if you flipping it down?
So if you think about it graphically, negative power 3 is here. Positive power 3 is here. So the sign is only opposite different by a negative. You can also have the cosine in the similar fashion. Except cosine does not have the negative in there, so. Is that right? No, I wrote it wrong. Dumb. Got way ahead of myself. There it is. There you go. Okay, so cosine of any negative angle is the same as the cosine of that angle, as opposed to sine where the negative had to be up front. So if I ask you what the cosine of negative power 4 is, it's the same as cosine of power 4, which is 2.
So this also relates to just moving everything back to the quadrant 1.
Yeah, once again, we're moving back to quadrant 1 if we can. Okay. Again, not absolutely necessary. It can be helpful. Something you've probably never heard before. Cosine is an even function, and it's defined very much by this. An even function takes the opposite of a value, and the output is the same as the positive version of that value. An odd function, very weird. You input the opposite of a value, it's the same as the output negated. Okay, so those are even and odd functions. We don't stress it because it doesn't come up often. Once in a while. Pretty much once in a while. Okay, so any questions, those two slides? I don't understand anything. Okay, moving on. All right. The meat of this chapter is what we're going to start.
Wait, that
So,
was
in order to solve a trig equation, I'm not calling it the easy part. I'm saying that
You can only get
the main point of the chapter is to be able to solve trig equations.
Can't do that.
Okay, so where does something like this, how do we solve that equation? Okay, at this point, you're going to look at the unit circle and just try to plug and chug it out. Right? So where would maybe sine be -1 and cosine 1? Is that possible? No. How about negative root 2 and positive, or root 2 over 2 and positive root 2 over 2?
Probably 5 and 4.
Okay, so right now, again, unit circle.
No, they're just spitting it out.
Cosine and sine, right? If I add those two up, gives me 0, correct? That is 3 power 4, or 135 degrees. Where else might that occur? Not 5 power 4. Good guess.
7 power 4.
Yeah, 7 power 4. So we have root 2 over 2 and negative root 2 over 2. Okay, so at this point, you have to like think through those. And that one's possible. Okay? But what if I get more complicated? We have to simplify them before we can solve them. Okay, so that's where we start. We start by simplifying expressions. Okay, much like what I showed you earlier, what was on the warm-up. Okay, simplify that, make it as simple as possible. Yeah, it's tangent x cotangent x. Yeah, that's what we put on the board. Okay, again, what's one of those tips that I told you? Change to sine and cosine.
Yeah, so cosine or sine plus
So,
sine.
again,
It just cancels it.
so there's the simplified version of tan x cotangent x. Okay.
How do we use that at the top then?
Okay, so these are going to get a lot more complicated, so that you have to do stuff like this in order to solve them. Okay, so you're going to get much more robust equations that you have to simplify the trigonometry before you can get to this point. Okay, this is easy version. Okay. So change to sine and cosine is a very valid technique there. What else do we do? We use some fraction math, right? Cross cancel. Okay, so that's another one of those tips I think we've stressed. Let's look at another problem. Good. Pay dividends. Okay. Simplify that expression. Sin x plus sin x cotangent squared x. This is a different problem. Okay, the other tips, we'll use your algebra skills, mainly factoring, if you can. If you can factor, do it. And use your identities. Okay, what can I do with that?
You can make the cotangent, or cotangent squared. What do you mean? Cosine squared over sine squared?
You could. Okay, let's go with it. Cotangent is cosine over sine, right?
Yeah.
Okay, did you just use an identity?
Yeah.
Yeah, you did. Okay. What next?
Could you square, it's not equal to anything, so you couldn't square sine and the sine.
Sort of interesting.
We can cancel out one sine top and bottom.
Oh, yeah.
Okay, so we end up with what? For the plus sign between them, do not cancel. Look at your tips. All four of them, what is something that you could do?
Could you put a 1 over the sine and then
Negative factor.
that would change?
You're thinking, keep thinking. Okay, we've already done this.
Yeah.
So we have to do fraction that.
Is there a way we can use that?
Yeah, if we make a fraction out of the sine x.
We're adding fractions, can we have a common denominator?
Yeah.
So I'm going to do a common denominator here. Right? So we get sine squared plus cosine squared over sine x.
Then could you cancel the sign with the one on top?
There's a plus sign between them.
Oh, yeah.
Doesn't that just
You can't cancel these. Besides that, we just put that there for a reason. Anybody know what the top is?
Sign,
So you just take out the
Sine x, sine squared plus cosine squared is
tangent square.
an identity. One.
so what's wrong with sign?
That's an identity.
Oh, so that's
So identity. And then 1 over sine is also an identity for cosecant. A little more. The answer is more simple than the original, right? So we can get there more easily.
How can we get that more easy?
You're thinking. Okay, what did we not use?
What do we not use? Factor?
Factor. Can we factor this?
It's plus what could be
What can we take out of both terms?
sign
So here's one method, here's number 2. Factor a sine x out. Okay, I'm gonna make notes here, factor. Okay, well now. Again, look at your 4 things. Which one could we use?
Is that cotangent or cosecant?
Cotangent.
They can do this cosecant over sine. Or the, yeah, cosine, sine.
You could. Less helpful than what I'm thinking. Yesterday we talked about the Pythagorean identities. What is this equal to?
sign x plus cosine.
1 plus cotangent squared is?
1.
You can reference your notes in your book here. That is an identity. One plus cotangent is cosecant squared. Okay? What else can you do? Okay, it's just step by step. I know it's tedious, but you have to think through. Cosecant squared is?
Cosecant times cosecant.
1 over
Sine.
sine squared.
Oh, and then 2.
Now we can cancel,
Yeah.
and we end up with cosecant. Again. I have no idea what that is.
What is going on?
Moving on.
Isaiah, can you take your phone?
You have, if it causes more interruption, I'm just going to take it. Do you see how we use those 4 items? Like, you have to look at each step and process it and say, what can I do next? And I'm giving you those 4 tips because that's what you need to use. Okay? Do you have any questions on any of these steps? There's an application at the end of the lesson.
Is that I-O?
I will go ahead and write it down, I'll explain. You guys know what polarized sunglasses are?
Yeah. See the water leak.
Yeah, they take glare off, right? Okay, well, what they do is they change the angle that the sunlight comes in, and they actually change the intensity as well. Okay. This is the formula that governs how much light penetrates a polarized lens. Yeah, pretty cool. Can you simplify that expression?
You could.
So, do you know what subscript is?
I know
Okay,
there's,
so what this is saying is the intensity that passes through, so that's what actually gets to your eye, is the initial intensity that hits the lens minus the initial over cosecant squared of the angle that the lens bends the light. These polarized lenses, they bend it. If they actually change the angle which the light comes into your eye, that's how they work. Okay, so, sunlight intensity, output intensity. So, in trig terms, we can make this a little bit more simple. Possibility. Mr. Briggs. The factor? Yeah, sure. Algebraically, we'll go with it. Right. So again, you're using those 4 tips, right? Run through them. 1, 2, 3, 4. What can we use next? You gotta think.
Is that identity 1 over cosecant?
Yeah. Okay, there is an identity for 1 over cosecant.
so then it's sine squared, right?
That's, yeah, sounds good.
Yeah, it's okay. Okay, so for making notes, we factored, and then we used an identity. We all came up with those.
So if you just don't know the identities from yesterday, you should read.
I'm not asking you to memorize them, but they're all there for you, right? We wrote them down, and we will have memory cards with all these on them, so you'll have that reference. You just have to look for them and think it through. Are we done?
No.
Is it 1
But is it, what's, is it 1 minus sine squared?
That's a Pythagorean identity.
Intensity equals intensity of clouds.
Okay, look at your notes. Again, you can use your resources here. What did we write down the Pythagorean identities yesterday? Say that, Dylan?
What?
You say it?
Probably not.
Maybe.
Is it the sine squared x? Nope, I didn't. I don't know.
It's a,
Maybe it's
I know, I could see that.
right. I don't.
Sine squared x plus cosine squared x equals 1. Is that what you're reading? What's below it? We wrote down a couple more right below that. 1 minus.
I don't have that one.
Oh, write down. Indra.
Tangent squared x plus 1 equals secant squared x.
Doesn't match, right? What is there a 1 minus sine squared identity?
I feel like this is a trick question.
It's not a trick question. We wrote it on the board.
I mean, is the answer yes?
Okay.
Is the answer
Squared.
yes?
Okay, cosine squared is 1 minus sine squared.
Oh, I know.
You did?
Yeah.
Come on, man. You set me up. He'll give us the answer eventually. Okay, so what am I going to put here? Yeah, substitute. I don't know, Tyler, is it as far as we can take it?
I asked you.
So if you look at that equation, do you think using those 4 things that I told you, that you can simplify that anymore?
Is the IO its own variable?
It's the initial input of sunlight.
Okay.
We have nothing to do with that.
Okay, I think, yeah.
Yeah, you're right. Because we cannot, it's already sine and cosine, we can't factor, there's no fractions to manipulate, and there's no identities that we need to put in there. We're good. That's pretty simple. If you were given an angle and an initial input of sunlight, you could figure out the output using what your current knowledge. So we're good. All right. Okay, I want to give you one and see what you got. Okay.
Tyler, are you holding that helmet? Dude, I don't know. Yes. My 2 feet can't hold myself. I'm not going to hold you.
Okay, here you go. Simplify this.
I just did half those notes for that one file on one page and half on a different page.
Cosecant over cotangent.
Cosecant theta divided by cotangent theta.
Okay, so for some identities, fellas.
Cotangent is cosine over sine.
Well, cosecant is equal to cotangent plus 1, so we can just change
1
that.
over sine.
That would be careful.
Cosine over
Can you
sine.
just tell me careful?
Yeah, I did.
But it's in my notes.
No, that one is, what you just said is not in your
It's
notes.
secant.
It's got to be squared.
Sure, then apparently I forgot about the square in my notes.
I thought you said 1 plus. Yeah, squared. Squared.
Cosecant
This
is
is
1 over
squared.
sine, and the cotangent is cosine over sine, so we just take them. So it's 1 over cosine.
We use a book to see what it's all
Wait, what?
about.
Say that slower.
Real quick.
Cosecant is 1 over sine, and cotangent is cosine over sine, so you take that sine and both, and it's just 1 over cosine.
It's on my paper right here. It's on the same paper.
So that's fantastic.
This one's not.
Okay.
Cosine
Oh, it's this one, it's this one.
which is
Okay, hopefully you're right.
Because 1 over 1 cosine, 1 over sine, cosine over sine.
Okay, it's this one. One of them, I said that.
Yeah, that's just, again, to show you where a little more organized. You can put equals. You can start 14 to 17 is the word. Yeah, I got it. Who's struggling? Okay, tip number 1. What do you think?
That's what I was doing.
Okay, 2. Sine and cosine. Good. Sine and cosine.
I want a piece of paper.
Why do you need a piece of paper? We don't got homework.
We can't do tomorrow.
Small ones. There's a piece of paper. What kind of piece of paper? That one right there. This one? Graph paper? Graph paper? This graph paper? Just give me that. This one? Yes.
2, 3, 4, 6, so it would be 2, 5. 6, 4, 3, 7, 5.
Oh no. Now, that stuff you ordered for the past week. She's gonna add. Hold on.
My leg can't bend. I got bent down.
We don't have to.
Wait, show the time.
You don't even need it today. You have to have
You want to see what I'm doing?
I don't want your stupid cash. It doesn't make you watch the win.
Hey,
You're right.
so I'm only adding, this is today's work. It's not due until Tuesday. It's only 4 problems. Okay? Again, I want you to dig through this stuff. You have some problems due tomorrow, 9 through 11, and spiraling. Who's still stuck? Why?
Yeah, the one yesterday was 9 to 11.
It's that.